In this walkthrough, we are going to complete our customer list class. We have starting code, but we need to add the indexers. We are going to add the change handler, the delegate, the event. We also are going to add the add, remove, and then our operator options here to subtract and add to our customer list as well. To get started, we're going to come over to our creating the solution. We're going to go ahead and copy the code and then switch over to Visual Studio. And in this case, we're going to create a new class. This is going to be where we add a new item. This is going to be customer list. We're essentially going to collapse and select everything for our class definition and replace it with what we copied in, and it has a few things for us. Now, as we transition and try to use the books methodology on creating our list class, there are a couple things that we should point out. Now, in this case, we have our constructor. It looks a little bit weird. We've never seen our constructor quite coded like this. Essentially, that's the same as if we went ahead and did this. So that would be the same thing. They're just using that short-handed expression notation to do that constructor. So in case that throws anybody else, you can always change it out to be the normal constructor definition. We also have a property. This property is going to return essentially the count for our list, and this is only going to be a property that we can use to get information from. We can't necessarily set anything from that. We also have a fill method, and in the fill method, essentially the book is going out and reading in data from a file. Well, we haven't even covered files yet, so I'm not sure why they're actually doing that at this point. But they're retrieving data from a file, reading it in. In our case, we're just going to use some hard-coded values until we get to the point that we use a database. They also have a save database method, and in our case, we're not going to be actually using anything to save to the database yet. They're saving their contents out to a file. Again, we haven't studied files, we haven't done databases, so we really have nothing to save out our content, and therefore we're not going to be using that at this point in the semester. We also have the toString that's coded out. So those are going to be our starting bits. We have the fill with a few customer records that it's actually adding to our list. So we have some data to begin with, and then we have all these other things. Now we're going to tackle these things, and the first thing that we want to do is we want to go ahead and do our add and remove. And let's put them underneath our fill. And if we think about our add and remove, all we really want to do is have a method available that's not going to return anything, and it's going to be an add. It's going to accept a customer record, and then essentially going to add it to the customer's list. So this would be customers.add customer. Now when we start implementing our delegates and events and stuff logic, we're going to put more stuff in here, but this is really what we need to have now. And we're going to essentially copy this. It's going to be very similar for our remove. We're going to retrieve a customer. Somebody's going to pass it in. And then essentially we're going to remove that customer from the list. So that's pretty much those particular methods. Then we're going to go ahead and add our customer list, the static operator, the add to the list, and then we have the subtract. So this is going to be very similar to what we had previously in the last lab. This is public, static, customer list. That's going to be returned. We have our operator, and this is the plus. And we are going to have a customer list. We'll call this list, and then a customer, and we'll call this C. And I'll move this to the next line. Here we're basically going to take our list and add our C, our customer, to the list, and then go ahead and return the list. And that's going to be essentially what we're going to do for our customer lists. Now, when we are going to do our static for our minus, it's going to be very similar. We're going to have a customer list being passed in. We're going to have the customer being passed in. Instead of add, we're going to remove from the list and then return the list. So that's going to take care of those. Then if we go back to our UML diagram, so we've tackled the add, remove, and the two operators. We have our fill, we have our constructor, we have our toString. The only things left that we have are indexers, and then we have logic that we have to put in place for our delegate and our event as well. So let's start with the indexer. That's going to be the simplest thing that we need to do, and we're going to do this two ways. We're going to do an indexer that's based off of a particular field, and when they use this instance with the field, it's going to go out and retrieve a record based on that field value. We're going to use the email address because typically that's going to be a little bit more unique than the first name last name combination. And then we're also going to use an index value as the indexer as well. So we're going to do it two ways. Let's start with the way that we're creating it with essentially that unique email address. Going back to our solution, and I think I'm going to put it above the add. This is going to start with a public. We are going to return an instance of our customer if we find it. We have our this instance, and we're going to be passing in a string value, which is going to be the email address. This is going to act more like a property. So we're going to have essentially a get. And within this, we could do a little validation to make sure that our email address has an @ sign or something like that. But in our case, we're just going to go ahead and check to see whether we have a value. And if we do, then we're going to return that. Otherwise, we're just going to return null. So we're going to set our initial value that we want to return. In this case, let's make this a variable customer. We'll call this cust. We'll set it equal to null to begin with. And we're going to return our cust value. Let's go ahead and make this a nullable. So that should make that happy. And make this a nullable. And that should be happy. And we're going to essentially iterate over our customers and try to locate that. So our customer, and we'll call this customer in customers. If our customer email address is equal to our email address, that's what we want to do. Then we're going to go ahead and use curly braces, set our cust equal to customer, and do a break. And that should essentially do that. So we're either going to be returning null out of this, or we're going to essentially have a value coming out of our loop. We found a customer, and that's what we're returning. So either way, we're going to have a value. It's just going to be on us to determine whether we got a value back before we try to use the value for any purpose. So that was pretty easy. And essentially, we're going to do essentially the same kind of thing. But in our case, we also want to do a set for this. So this is going to be our indexer with a value. So this is going to be public customer this, and this is going to be having an input value of I. This would be like if we were trying to index into an array, we could use an integer value to do that indexing. We're not exposing our list to the outside, so therefore they have to call this and provide us an index to actually get a record out. But if they send us in a particular index value that's beyond the limits of our array that we have, or our list elements that we have loaded into our list, we need to give them some type of messaging. And the messaging, the easiest way to do that, returning it, is to throw some type of an exception. So in our case, we're going to check to see if our I value that they passed in is less than 0, or the I value is greater than or equal to, because remember, our indexing starts at 0 and is actually 1 less than the number of elements in our array. So our customer account is going to be beyond the end of the array by 1 element. So if it's greater than or equal to the customer count, then we want to go ahead and throw a new out of range exception. And based on what they were showing us in the book, they actually wanted us to do an I2string. Let's go ahead and put an I.toString. And if we don't have something that's beyond the limits of the array, we're essentially just going to go ahead and return that entry from within that array list that we have. We also want to go ahead and do a set. And within our set, we essentially want to get the value in. And when we get something in for a property, it's always going to give us the value in the value parameter. So whatever we get from a property, it's going to be assigned to this value. Then we can take that value and assign it to anything at that point. And that's essentially all we want to do for that at this point. The next thing that we want to do gets into our delegates and our event handler. Before we define the actual delegate, we need to kind of understand what a delegate is. And a delegate is a type that represents a reference to a method with a specific parameter list and a return type. We can instantiate a delegate. You can associate it to an instance with any method that matches the delegate's signature. You can invoke the method through the delegate instance. And the reason why we use delegates is that it provides type safety. The delegates provide a type-safe way to handle method references, ensuring that the method signature matches the delegate signature. It applies additional flexibility to our applications such that they allow methods to be passed as parameters, enabling dynamic method invocation and callback mechanisms. And they are used as part of the foundation of event handling in C#. So that's kind of the why and what they are, and we're going to go ahead and try to use it in our case. And we are going to create a delegate at the very top, and this is essentially going to define what type of method, when we create it, it has to have the same type of signature. So the delegate is just going to provide essentially the template for what method we have to create. So in this case, we're going to define it with a void return type. We're going to call it change handler. And it's going to have an input of customer lists. We'll call this customers. So that's our delegate. Then we are going to have an event that we need to create as well. And this is going to be public event. And this is going to be change handler. And we are going to call this changed. And we're going to set it equal to null to begin with. Now, as we go ahead and we make changes to our list, one of the things that we want to do is we want to raise the event that says, hey, something got changed. And then when we get into our code and utilize this class, we can set up our change handler basically using the syntax of this delegate, which will receive the notification of those events, and then we can do something with it. Everywhere that we are making any type of change to our list, we need to signal and raise the event so that our application that's going to utilize this class can get notification that there has been a change, and then it can do something, whether it's just going to write some message out to the screen or whether it's going to use it to refresh something in a user interface. We can use it in various different ways. We have our fill. Our fill is going to update and add things to our list Therefore, we need to signal that that is going to be changed. And if we start entering this, change is not equal to null, and then this is going to be changed, passing in the this instance, putting in our ending curly brace there. Notice that if we give it a second here, it should show us that we can simplify this delegate invocation, and essentially it's going to show us what that change is going to be. It's going to be a one-liner that's essentially going to invoke that delegate instance when there is a changed event that's raised. So we're going to use the short form and copy it down. We are going to place it anytime that we have made a change. We're updating our list here with a value, so we would want to indicate that there is a change that has been made to the list. If we come down to our add, we have a change that's being made to our list. If we remove something, we have a change that's being done to our list. We have these static methods down here. We're not going to actually add anything here because we're passing in an instance of this list and it's executing and performing the add and remove for our plus. So in this case, it's going to call this method here, which has that invoke. And for the minus, then it's going to call this one. So it's already taken care of. We don't need to worry about those two. And that's essentially everything that we have for this class. So that's going to take care of all the coding in this class. Our next video is going to go through and test everything that we've done.